This week we're going to start looking at triangles and trigonometry. This first example, we have two side lengths and we want to know the third side length. Let's call it B. We can use Pythagorean theorem, a squared plus b squared equals c squared. Rearrange. Calculate out. Now we do get plus or minus, but it's a length, so it has to be positive. Here, we want to find the length of x, and we can use trig to do this. Now remember trig, you have so, ka, toa. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So if we look at this example, the 35 would be our hypotenuse. The x would be adjacent because it's beside the 60, so we're looking at cosine. So cosine of our 60 degrees is equal to adjacent over 35, the hypotenuse. 35 cos 60 equals x, and we get x equals 17.5 meters. Here's another example where we're looking for a side length. This time, we're going to use tan. Tan of 27 degrees is equal to opposite 7.5 over adjacent y. Now this time our unknown is in the denominator, so we have to be a little extra careful in our solving. We can answer 14.7 feet. We can also use trig to solve for an unknown angle. In this case, we can use sine. Sine of theta is equal to opposite over hypotenuse. So theta will equal sine inverse of 25 over 60. And we end up with 24.6 degrees. Here's another example of looking for an angle. This time it will be tan. Tan theta equals 22 over 14. Theta equals tan inverse of 22 over 14, or in this case, 57.5 degrees. We could also solve non-right triangles. Our regular rules of SOHCAHTOA and Pythagorean theorem will not work on a non-right triangle, but we do have the sine law and the cosine law. In this case, we can find this third unknown angle by doing 180 minus the other two, which will be 65 degrees. And then we can use the sine law because we have this angle inside known, and then we can use this angle inside as our other ratio. So we want x over sine 67 equals the 14.5 over sine 65. So x will equal 14.5 sine 67 over sine 65, which is 14.7 meters. In this example, we don't have an angle and opposite side known, so we're going to use the cosine law. So in this case, x squared equals 16 squared plus 19 squared minus 2, 16, 19 cos 70 degrees. So you'll notice it's similar to the Pythagorean theorem, but we have that extra bit on the end to adjust for it not being a 90-degree angle. From here, we can calculate it out. And then this is approximately 409.05175 we take the square root of that, and we will get the answer of 20.2 millimeters. Here's another example, and this time we're looking for the angle. We are going to use the cosine law. Now, whether you use the cosine law and the a squared equals b squared plus c squared minus 2bc cos a, or the rearranged form of it, we will get theta of 71.6 degrees. Now let's do a couple of word problems. With the word problems, it's usually best to draw out what is happening. In this case, we have a surveyor standing 120 meters away from the base of a building. Assume a right angle. We know that the angle of elevation is 22.3 degrees, and we're looking for the height. We can use tan. Tan 22.3 degrees is equal to opposite over adjacent. Rearrange. Solve for h. So therefore, 49.2 meters tall. This example, we have a ladder leaning against the side of a building. The ladder is 3.2 meters, and the height of the house is 2.7 meters. Again, assume a right angle. Now, the ladder, to be safe, it must be less than 65 degrees with the ground. So we need to figure out this angle. So if we use sine theta equals 2.7 over 3.2, so theta equals sine inverse, giving us 57.5 degrees, which is less than the 65 degrees. So it is safe. Here we have an example that's not a right triangle. We have a hill that is 18 degrees, has a tower on it, and then we know there is a support wire for that tower that is 15 meters up the hill. Now assume that this forms a right angle with horizontal. So we can use that 18 degrees to get, this is 72 degrees, 90 minus 18, which also means this one's 72 degrees. And then let's label this theta and this gamma. We can figure out all the angles and use sine law. Okay, so sine law to figure out the one angle, and then sine law to figure out the unknown length. So let's start with theta. Sine theta over 15 equals sine 72 over 25. Rearrange, we'll get theta equals sine inverse of 15 sine 72 over 25, which is about 34.8 degrees. Once you have that, you can do gamma equals 180 minus 72 minus 34.8, which is 73.2 degrees. So now we know all the angles of the triangle. We can now use that to figure out this height. So we can use sine law again. H over sine 73.2 degrees equals 25 over sine 72 degrees. Solving for h. Gives us a height of 25.2 meters. One last example. This one has to deal with a helicopter flying, some headings, some speeds, so it's got quite a bit going on. Now this one's a little bit more complicated than some of the others, but this kind of ties in with a later unit as well, and it kind of ties in with your physics courses. So the 30 kilometers at 30 2 hours at 30 kilometers gives us a distance of 60 kilometers. And then the 1.5 hours at 32 gives us 48 kilometers. So we know the distances. Now it's nice to draw a decent sized diagram here. So we have the first leg going 60 kilometers at 38 degrees west of north. And then it makes a turn and goes that's 71 degrees, and it goes 48 kilometers, and we want to know this distance. So we can use some information we know. If this is 38 degrees, then this is also 38 degrees by parallel lines, which means this angle is 109 degrees. So we can use cosine law. So d squared equals 48 squared plus 60 squared minus 2, 48, 60 cos 109 degrees. Calculating that out, taking the square root, you'll get a d of 88.2 kilometers. So that's your distance. You can use that to figure out the time pretty easily. So in physics, we know distance equals velocity times time, which we used earlier. The 2 hours is the time, 30 kilometers per hour is your velocity, gave us a distance of 60 kilometers. So we can rearrange that. So time equals distance over velocity, which will be 88.2 divided by 35, which is about 2.52 hours. So the time is about 2.5 hours. From there, we need to figure out the heading. And this is where it gets a little tougher. First thing I'm going to do is find this theta using sine law. Sine theta over 48 equals sine 109 over 88.2. So theta equals sine inverse of 48 sine 109 over 88.2, which is about 31.0 degrees. And then we can use that to figure out this angle over here. If this is 31 and this is 38, this angle will be 90 minus 38 minus 31, which is 21 degrees. And then this angle is also 21 degrees. So this one would be 69 degrees. So our heading is south, 69 degrees east. Now, this question, as I said, is a little bit tougher, and we are going to touch base on it again in a later unit. At this point in the course, the only thing I would put on the assignment from this would be finding the distance.